I see a couple of things. My name is Ebenezer. I'm a PhD student. And as usual, burning has always been left for the last. When everything fails, we burn it. So that's what I'm here to talk about, burning and low carbon fuels. And I'd like to say that this presentation I'm about to do, I did in conjunction with Rob Cummings of Lafarge Cement Group. And there's a lot of inputs in there. And he's the expert in the cement kiln and fuels too. So if your questions are a bit way overboard, I know who to direct you to. But yeah, I am also in the field of low carbon fuels, and I study fuels of different kinds for cement kilns. And it's local based, and so I work in Brookfield. There's a kiln in Brookfield in Nova Scotia, and that's where I run my tests. And I also work in conjunction with two groups, which is a typical example of intra-academia research. I work with atmospheric forensics, where they're checking the emissions, which is next to a lab where they check fire and explosion. So I do those two things together, and that's how come I apply these things to cement kilns. So today I'll just be talking about low carbon fuels, what they are, what the legislation has called them to be, what is happening now with low carbon fuels. Why are they called low carbon fuels? Why are they no more being called refuse-derived fuels or waste-derived fuels? And then I'm going to give a brief overview of the cement production industry. And then I'm also going to talk about how we blend low carbon fuels into the cement plants and the experience so far. And I'll be focusing on the experience of Lafarge Cement, most of it. And then the opportunities for increased LCF use in cement kilns, the goals, the regulations, and the research that will drive this increase. And then I'll finally conclude. I know it's usually burning is not seen as a science, but when we study combustion into detail, you find out that it's so advanced of a science that very little changes have very big impacts. And I know Professor Dr. John Wen will appreciate that also. So basically, low carbon fuels, and a simple equation where we say that, well, when we burn anything, if it has carbon in it, we produce carbon dioxide. If it has anything else in it that can oxidize, then we produce the oxide of that. And what it means to call something a low carbon fuel is that on a gigajoule to gigajoule basis, meaning on an energy basis, on an energy comparative basis, I produce less carbon dioxide than my reference fuel. The reason why we do this on an energy basis is because most of the time there is a misconception of masses when we use mass. In that, for example, plastics contain about 42,000 kilojoules per kilogram of energy, and coal has about, say, 30,000 kilojoules per kilogram of energy. So on an energy to energy basis, I need less plastic to produce the energy that coal will produce. And in that case, because of this reduction, I'm also going to have a repercussion in the reduction in carbon dioxide because of the content of carbon in plastic. So I'm not only reducing CO2 because of the content of carbon in plastic, but because of how much plastic I need to produce the same amount of energy. And so that's how come this term low carbon fuels has been developed. And you will find out that we're transitioning from waste-derived fuels because the terminology, it's a philosophy, and the term waste itself carries with it a stigma that we've encountered even in the communities that we are in. Because when we say that we're going to get energy from waste, they say, well, it is waste. But when we say we're going to get energy from a material, they are so enthused about it. So just the term waste has thrown this whole idea into a cycle that we have to always regenerate new ideas to get people on board. So basically, low carbon fuels is what, and legislation in Ontario has typically defined it as alternative low carbon fuel. So that's the terminology we are going with these days. And you can have examples. Waste materials can be low carbon fuels, and then virgin materials can also be classified as low carbon fuels. Now, typically, I would like to bring it on board. Now, we've spoken about so many ways of getting energy from waste, but cement production is unique in a lot of ways. It's very unique in a lot of ways in that, first of all, the raw materials and the end goal, from getting from raw materials to the product, there's a necessity for the heat, and there's a necessity for certain type of raw materials. For example, limestone and clay, which give off, and limestone gives off a lot of carbon dioxide. So the necessity of cement makes it necessary for us to use limestone, which gives off about 60% of the carbon dioxide that comes off a cement kiln. So there's already a footprint to deal with when you're producing cement. And cement is produced in long kilns, and I like to describe them as a lot of limestone, clay, fly ash, and iron on their way to hell. So there's a burner on one side, and there are raw materials on the other. And as they approach high temperatures, about 2,000 degrees Celsius, this transform, they clinkerize, and then they form this material that we call cement that we use for all the infrastructure that we have. Now, the cement kiln is so designed that it's in itself, it becomes a scrubber because there's a lot of raw material and there's a lot of fuel on one side, and then there's a kiln, there's a stack on the other side that lets go of emissions. I wish I had a picture to show that, but I think I will do a good job in explaining it. Now, the emissions that come from cement kilns are therefore typically most of the emissions come from the raw materials and the chemical reactions that go with it. So we are transforming calcium carbonate into calcium oxide. So we give off carbon dioxide. But we do this in the presence of a lot of heat, which is generated by fuels, and these fuels contain carbon, and therefore they also produce some carbon dioxide. There are other oxides that are produced. And basically, to reduce the footprint of the cement industry, there are so many things they can look at. And the first, it's a fourfold strategy we can look at. The first one is to reduce clinker components of the cement, to reduce the clinker components of the cement, because calcium carbonate is giving us carbon dioxide. That's a very difficult choice to make because of the product quality. Then there's also to reduce the energy to make the clinker. Are we able to design processes so that we don't need 2,000 degrees Celsius of flame to produce clinker? And then this is one which is well within our range, to reduce or replace the fossil fuels, which is coal, with low carbon fuels, which is what I will address today. And then there's also the opportunity to replace limestone with other alternative raw materials. Most of the work that I have done is to concentrate on replacing fossil fuels with low carbon fuels. Examples I'll give as time goes on. In replacing this fossil fuels, what we are basically doing is that we are stopping the removal of coal, which is carbon in itself, and pet coke, which is the typical fuel in cement kilns. We are leaving it right there in the ground, so we are saving that. Now, the second thing we are doing is that we are taking things from the landfill, so we are taking out, so there's no CH4 from landfills. All these things are also being redirected into a cement kiln. And the final thing we are doing is that because they are low carbon fuels, we are also affecting the emissions at the stack of the kiln. So it looks like a three-pronged solution to a same problem. And I think the cement industry can play a huge role in forwarding the low carbon fuels in this direction. Then there are also other benefits for low carbon fuels, and it's not only just the greenhouse gas emissions. Low carbon fuels like plastics and other things, they have limited amounts of heavy metals. In coal, we can have some other metals that are also given off or are vaporized, and then they are emitted. Usually we don't talk about the health effects of emissions these days because it makes more sense or more political sense to talk about greenhouse gases, but the health effects of emissions are also affected when we use low carbon fuels, which contain less sulfur, less nitrogen, and less carbon at the same time. So it's a good approach to deal with emissions at the same time to deal with the need for energy. Now, cement production is different from incineration. So usually the first thing that comes to mind when we are burning is we are thinking about incineration, where incineration means that we can just be waste managing, burning the stuff and taking the ash and doing something with it, or burning to produce, say, electricity. Now, it's very different because in operating a cement kiln, the ash itself is incorporated into the cement. So usually there's less waste in the solid aspect. Then the fuel quality of it, the fuel quality for cement kilns is also is regulated by their own standards. So it's a self-regulatory system where the more the chlorine, the worse your cement. So you might as well get the best. So for example, technically, PVCs will not be allowed into the cement kiln. And PVCs will also give off some emissions that are technically harmful to people. And then also there was also the positioning of cement kilns in a hierarchy. For example, because if you look at energy as a product and we look at cement as a product, then technically what we are doing is we are taking a landfill-bound waste, landfill-bound material, and making it into a value-added product, which is cement, which is well needed across the world because of the infrastructural development that is going on. But if you look at incineration directly, what we are doing is we are disposing of it, and we have to find a way to deal with the ash at the same time. But in the cement kiln, we are making a new product which is essential to population growth. So in talking about the differences in the two, I'm going to talk about the experience of Lafarge. So they're using so many different types of low carbon fuels and low carbon in different ways. So we're looking at asphalt shingles. We have so many million tons of asphalt shingles. For example, in Nova Scotia, that were lying down. We didn't know what exactly to do with it. So basically, shingles having high content of asphalt, which is energy burdened. There's some separation because there's a landfill site where there's some separation that is done, which is one of the main things. The pre-processing is usually mostly mechanical, no chemical pre-processing, which saves us a ton of time and energy. But the mechanical processing is also it comes with its own problems. So I'm just concentrating on Brookfield because that's where I come from. I mean, that's where I'm working. And then there's also non-recyclable plastics, which they started working on. I think tomorrow they're going to be commissioning a plastic handling system with asphalt shingle handling system. And then there is C&D, which is usually made of wood, and then unrecycled plastics, non-treated wood, and some plastics in there. That's what they use in Brookfield. When we're coming westward in Bath, they use way more. The cocktail is bigger. So asphalt and railway ties. And this is localized. It's based on what we have in a local municipality. So you can pick these ideas and apply them in local municipalities. And if there's no cement kiln in the municipality, we can look for a neighboring cement kiln to use for that. K-cups, which we talked about today. Carpeting, which is also a big deal. And then non-recyclable packaging and C&D in Bath, Ontario. In Saint Constant, which is I think in Quebec, we use tires, which is scrap tires, C&D and shingles. But BC looks like it's the most advanced in using alternative low carbon fuels. And the cocktail is large and wide. In Extra, Alberta, where they use natural gas because they have a huge supply of it, I think they are still undergoing studies because most of this is driven by a motivation and a need to cut down on cost. And that's why it's also a two-pronged approach. We are helping the cement industry at the same time helping the environment. So because of the vast experience that Lafarge has had, there are some specifications they've come up with because of the experiences we've worked with. Now, the energy value is, we have a range of energy value, and that's where maybe you get some plastics and some shingles. The energy content of the material should be big enough. It should not have too much moisture because moisture will take most of the energy out, and then we'll not be able to hit the temperature range that we need to clinkerize our limestone. And then there's also some specifications on the carbon content, on the homogeneity of it. And how we come about this homogeneity is the problem. Who does it? That's what I think I was discussing with some of the municipal leaders. Who does it? And that's the question. And then removing of the non-combustibles to be used for cement kilns. So some of these things are specifications that they look out for. And I put some pictures of the things they work with currently. Now, the opportunities going forward there are three things that will drive the use of low carbon fuels in cement kilns. The first thing will be favorable regulation, which we are beginning to see, because even in defining what alternative low carbon fuels are and giving the science good recognition in policy, it's become easier for us to basically determine what is a low carbon fuel and what the benefits are. And that's what Ontario is doing. I think there's a website that leads to the regulation. It clearly defines what an alternative low carbon fuel is. It's a big step in the direction, and then also has systems for approval testing. And in Quebec has had a long-standing policy on recognizing what this is. They don't call it waste usage, they call it valorization, which is also positive. In Nova Scotia, we've developed a testing protocol for LCF, which is good. Therefore, somebody can bring a fuel for testing, and then we tick on it to see whether it is good for cement kilns or not. So we're not just grabbing everything. And in Alberta, there's still, I think the carbon tax and all those things in BC are all helping in driving things towards low carbon fuels, because coke and petrol and coal are becoming more expensive with the taxation that comes with it. So there's a drive towards it. So there's motivation on the regulation section, on regulatory sector. Then also there's opportunities for increased LCF in the future because of the innovation of the cement plants themselves. And I think that this is driven by the motivation to cut down costs most of the time. So, for example, in Lafarge, like I mentioned, tomorrow they'll be in Brookfield. They are trying to get to 30% substitution, and they are opening it just tomorrow. There are consultations in Ontario to see if plastics can be used. There's a motivation for the cement industry, and because it also behoves on them to get the quality of the clinker, they have a sort of self-regulatory system where they don't accept anything at all to create more waste here and there. And it's actually positive. And most of my schooling in PhD has been funded by these cement industries and then governments who are trying to get waste out of landfills. And so quickly, in the next 5 minutes, I'll run through. So because of this, some work has been done in the research sector for LCF, and I just want to present a couple of things. So these are the opportunities we have. We need to study the combustion kinetics. Now we see them on the macro scale. We see what happens in the kiln. What is happening on the kinetic level? What is happening when we put coal with plastic? If we understand it more, then we can see how we can bring in more fuels. And then also, we have to test them on the basis of emissions. So that's what my work has been over the 4 years. So I've used literature work, conducted all over the world, predictions based on elemental analysis, which a lot of policyholders use as a preliminary check, and then experimental determination of combustion products. So yes, my prof, Dr. Gibson, standing by an equipment attached to a lot of testing devices. We check emissions from a lot of experiments, combustion experiments. Some of the results we got, for example, when we're talking about C&D plastics, is that we see clearly from calculations that there's 34% decrease in fuel CO2, straight away qualifying it for a low carbon fuel. And then there's, if you look at SO2, which is 98% because of the sulfur content in the fuel. But there's a lot of sulfur in the raw material, so we don't know how that will translate into actual SO2 savings. But on a fuel level, there are savings in NOx and all that, and there's only an increase in H2O. So some of the work we've done in our lab has given us this result, and therefore the approval to test some of these fuels. And then we also did some work in separating different types of fuels and how well they will combust and what will be the benefits and the savings. And we look at C&D plastics, plastic film, which we talked about today, textiles and clothing, and then carpets, containers. And you can see on the table that even though they all both are in a family of plastics, there are so many differences in them. And usually look at clothing, for example, because of the additives and the things that they go through, the gaseous emission savings that we make, for example, in CO2 was less, say 16% for clothing. And then for C&D plastics, there's like almost 34%, like I mentioned, decrease in gaseous emission. And then in containers, these are HDPE containers, there's also 18% decrease. So we've done some of these tests and then we've done this analysis that gives go-ahead for some of these low-carbon fuels to be used in cement kilns specifically. We've not done any work in energy recovery for electricity. So basically the conclusion is that there's ample evidence for the benefit of LCF as a resource recovery tool if it's used in a cement kiln. We also say that the cement industry has displayed considerable readiness to use LCF, the motivation being the carbon footprint and then the cost of production, which is their motivation. Then there are opportunities that exist for the expansion of knowledge in the science of LCF. How do these things combust? What's the morphology of coal when it's mixed with plastic? How does it move from volatilization to char? What does it do? And the study is huge, so a lot of academic research can go into it. We can get a lot of understanding from it. And then also we can look at well-informed regulatory modifications that are helping the drive towards diversion of these things from the landfill. So basically this is what low-carbon fuels are doing in creating a circular economy where there's minimal amount of waste and loss of energy. Thank you very much.